Hey, good morning. We're going to take a look at an FRQ that involves stopping distances with certain kinds of tires and all-weather tires in this particular problem. This is from 2009 AP test, question number 2. And the first question is, what is the 70th percentile? All right, so you're given the percentile. So what I'm looking for in this particular problem, first off, is a little sketch of the normal model. The mean has to be written in 125 and the standard deviation also with an n in front. That will be your first check if you've identified the kind of model it's going to be. The next thing I'm looking for is, are you have the right like percentile labeled. 70% is going to be down here. Percentile, remember, is always from the left. This one is an easier problem because they tell you what the percentile is. Normally, the harder problems are going to be, they're going to say the top 10% or the top 5%, and you have to make sure you're coming in from the left when you do your inverse norm. So the first check is going to be n with the mean and standard deviation. The next check is, do you have the right area labeled with the 70%? Okay. Now the next thing that I want to see is the z-score. So I'm missing it right here. Z is equal to the inverse norm of 0.7, which I actually know, I believe, is 0.52 for this particular situation. Now, my person did not show the work. They're not going to get credit for it, even though I know they did it on their calculator, but that does not give us a check here. The fourth check is going to be showing substitution into the z-score formula. Okay, I love how they have the formula. So we have x minus 125, which is the mean, over the standard deviation of 6.5 is equal to the z-score. That substitution is shown. And then the final answer is 128.38 feet. And so they do have that done correctly. Okay. They have some in-between work, but they're not going to get any additional checks for that. So there are 5 checks for this particular problem. My person gets 4 out of the 5. Okay. Part B, there's a sort of a sticky part in Part B. Even when I first read it, I thought, what is the P, the probability that I'm going to be using? I'm used to using it from a previous, like the A part. This one is a little bit different. Okay, B says, what's the probability that at least 2 out of 5? Now, just from that, you know it's going to be a binomial problem. So they are expecting you to write down that it is a binomial model with N and P. And so this person did do the binomial problem. They do have N, they do have P. They are going to get a check mark from this. Absolutely. It's not the way that I've taught you to do it. I want to see binom. Okay, I want to see N, the group size is 5, and this is the P. What is the probability that will stop in a distance greater than the distance in part A? All right, so here is the weird part. 0.7 is the area under the curve for stopping earlier than that particular number. What they want us to sort of recognize is that farther is going to be in that 30%. The probability that we're supposed to be using in this problem is the 0.3. Farther would be the 30% of the cars would be farther than the 128.38. I think that's the hardest part about this particular problem. Now, since my person does have this information, they are going to get the check, but I know that you will have written binom N, P to get this particular check for our first check mark. The next thing I'm looking for is P of x being greater than or equal to 2. So in this particular problem, I do not see it. So P of x being greater than or equal to 2 is missing. But they do have other stuff that's going to give them credit for showing their work. All right. So what I'm looking for is 1 minus binom CDF of 5, 0.3, 1. We're subtracting out the part that we don't want. My person does have the work for that. It's a lot more work than doing the calculator speak going on right here. Okay, so they're going to get credit. This is the way that I would expect to see it on your paper. And then the final answer is 0.472. Okay, they do have the correct answer. And there are 4 different checks here that I'm looking for. My person got 3 out of the 4. So I'm looking for the model, P of x, 1 minus binom, and the answer for the 4 different checks for this particular problem. All right, now part C, what is the probability that a randomly selected sample will have a mean stopping distance of at least 130 feet? This is a sampling problem, which is all about topic 5. Sampling with means, all right? And so the formula's on the formula chart that you have to use, that you know you're going to be using a normal model to solve the problem. Now, generally what we're going to do is, when I taught you to do the problem, we're going to check out the conditions, all right? 1, 2, 3, 4, and then we're going to have a since statement saying that we can use the normal model. Well, I'm going to tell you right now, for this particular problem on the AP, they didn't look for the conditions because they told you, okay, up above, that the population was approximately normally distributed, and that means that if you have a normal begets normal in terms of sampling. So that's why they did not really care about the conditions, but I would want to see them. Each car is independent of each other. The problem states that the cars were selected randomly. 5 cars is less than 10% of all cars. The problem is number 4. The CLT doesn't guarantee anything based on the sample size of 5. 5 is less than 30, and that sort of gives me a sad face. So I'm really not quite sure what to do with 4 here, except knowing that normal begets normal, all right? So we're good to go here. We know it's going to be normally distributed. So what I'm looking for in part C is I'm looking for, first of all, a picture of the normal model, okay, with an N. And now I need to figure out what the mean and the standard deviation are for this particular problem. So the mean of x bar is equal to mu, which is equal to what the original population is, which is 125. So I'm going to need to see 125 written in here. And the standard deviation for a sampling distribution of means is sigma over the square root of n. So I end up getting 6.5 divided by the square root of 5. Okay, and that particular number gives me 2.91. So the first thing that I'm going to be looking for on your particular paper is, do you have the normal model drawn, and do you have n, the mean, and the correct standard deviation here? If you do, give yourself a check. Okay, now the 125 should be labeled. You should have x bar, mean, stopping in a sample where n is equal to 5 cars. I know that there's going to be other things, but here, now I'm looking for shading. The stopping distance should be at least 130. So I'm going to label 130. At least means we're going to do the higher end. And if you have the shading shown, give yourself a check. Okay. Now, this particular person does not have either of these two things. They do not have the N. They do not have the shading. And so they're going to miss out on those first 2 checks. Okay. Now we're going to go to the P ofs, all right? So this thing right here, the first thing I'm looking is P of x bar being greater than or equal to 130. My person does not have that. All right, the sampling distribution, x bar is our sample of 5, is at least 130. That means it's inclusive, okay? Now, they calculated the z-score fine, all right? They actually incorporated the standard deviation, the recalculated sampling standard deviation in there. So it's going to be P of z being greater than or equal to 1.72, check. Now I'm looking for normal CDF from 1.72 to 999, x. Okay, and the final answer is 0.0427. They do have the correct answer here. And there were 6 things that I'm looking for in this particular problem. They got 2 out of the 6. Now the AP is going to be a little bit more generous because of their rubric. But in this case, the way that I've taught you to do the problem, I need to see a picture labeled with the model with the recalc mean and standard deviation. The correct shading needs to be shown. P of x bar, P of z, normal CDF, and then an answer for 6 points. So this problem is worth 15 points. I'm going to go up to the top right here. 15 points. My person, 4 plus 3 is 7, 7 plus 2 is 9, has 9 out of the 15 points, and that marks the end of this particular problem. Bye-bye.